Let's look at number 11 in section 2.2. We need to verify that the limit as x approaches 3 of 5x plus 2 is equal to 17. With techniques that we've learned already since section 2.2, we see that this is a linear function. Linear functions are continuous everywhere, so this is a just evaluate limit. If we plugged x equal 3 in here, we would get 17, so it's no big surprise that the limit of this linear function as x approaches 3 is 17. But what is meant by verify? So remember that the limit definition, which is on page 64, says that the limit of a function, so this is our f of x, is as x approaches c, so this is our c, is equal to the number L, that's our L, if the difference between the function and the limit can be made sufficiently small, can be made arbitrarily small as we wish, by taking x sufficiently close to c. So let's figure out what this absolute value looks like in this particular case. If f of x is our function, that's 5x plus 2. If L is our limit, 17, we'd have minus 17. And then what we're going to do is we're going to take this absolute value and then try to rearrange it algebraically so that we can get information about the difference between x and 3. Essentially, that boils down to just do the algebra, do some algebraic simplification. For instance, compute this difference. I get 5x plus 2 minus 17 is equal to absolute value of 5x minus 15. Notice almost immediately that I can factor out a factor of 5. So this is absolute value of a product. Here's one factor. Here's the second factor. That's the absolute value. That's the product of the individual absolute values. And the absolute value of 5 is 5. We got to leave the absolute value bars around the x minus 3 because x is variable. We don't know what the sign is for that one. But notice what popped up is information about the difference between x and 3. So what we can notice is that the difference between the function and the limit is equal to a multiple of 5 of the difference between x and c. Let me write those words. This is the difference between f and L, and this is 5 times the difference between x and c. Okay? And so, however small we want this difference to be, we just need x to be 1/5 of that size. However small we wish the difference between the function and the limit to be, we make x minus 3, the difference between x and 3, to be 1/5 of that. All right, that'll compensate for that factor of 5. Okay, this f of x is the 5x plus 2, and this L is 17. Okay?